Updates webinar for solar PV executives on inverter O&M. It would be really useful if you guys could write into the platform to let me know if you can hear me all good, just to make sure that everybody is able to hear right. Perfect. Thank you, guys. I can see your messages already. We will give it a few more seconds just to make sure that, more people get the chance to tune in, and then we'll start right away. Okay, perfect. So welcome, everybody. Welcome to New Energy Updates webinar for PV executives. We are doing this in partnership with NL Green Power and NREL. My name is Diana Droppel, and I will be your webinar host for this morning. So before we start, I'll tell you just a couple of words about us, New Energy Update, and the purpose of this webinar, because we do realize some of you haven't heard of us before. So who is New Energy Update? We are an organization that helps renewable energy executives anticipate the future. And we try to help to formulate plans in the face of constant change, right? So generally, we try to figure out how to do this. We do a lot of independent market research. We do webinars such as this one. We do content and international conferences, so on and so forth. So in solar operations specifically, we deliver this kind of information, webinar reports, white papers, and the idea and the point of that is to kind of provide you guys with valuable content that you can use to stay ahead of the changes that have a direct impact on your performance and production. So for this specific occasion, we will be focusing on how to improve your inverter O&M strategies. Reason for that is pretty simple. There needs to be there is always a space for improvement. It seems that insourcing versus outsourcing O&M is gaining an equal share of pros and cons, which is normal. Of course, that depends on the strategy that each company prefers, right? Anyway, I'm sure we will all agree that inverters are one of the most important pieces of equipment in a PV plant, which is why learning, O&M inverter best practice can lead to huge transformation, right? To huge equipment and O&M cost savings, and then also provide you guys with what you need to maintain and operate even other pieces like transformers, panels, and other major parts of your plant. So hopefully this will help you, improve your PV asset profitability. We all know that we're living in times of cost crisis. It's becoming more and more important. And keep in mind that we're always looking for collaborators. So if this is something that you're interested to take part into in the future for different topics, just let me know and we can start a conversation. Anyway, won't keep you any longer. I am excited to introduce you guys to Davide Grandi, who is part of NL Green Power as an inverter and O&M solar specialist, and Andy Walker from NREL. And so both of them will give you practical advice on how to do this. They are incredibly resourceful. They have prepared some great presentations, and they're happy to hear your questions. In short, they will be covering the latest O&M activities that are needed to optimize maintenance on inverters, and so they will walk you through a few maintenance routines and certain processes that are going to be very useful. And then they'll share some lessons learned from owner-operators that are moving from preventative to reliability-based maintenance. So it's a lot of good stuff. Remember that you can send in your questions at any time. For Q&A. There will be a part at the end where we will be trying to cover as many questions as possible. If you have any technical issues, just drop me, the organizer, a message directly. The webinars recordings will be emailed to all of you. So if you can't tune in for the whole time, that's absolutely fine. You will receive the recording in an email. And yeah, I'd like to thank everybody in advance. I hope you guys enjoy it. And over to you, Davide, to take us away. I'll share a notification now on your screen so that everybody can then see your presentation.
Alrighty. Thank you, Diana. And thank you to Energy Update for organizing this webinar. Thank you to Andy to be my co-panelist today. And of course, thank you for everyone, to everyone that is connected and it's gonna spend the next hour listening to us. So let's see, you should now be able to see my screen. Diana, can you confirm it? I think everything is set.
Yes.
Alrighty, so yeah, today we're gonna talk about what are the new strategies for inverter operation and maintenance. A little bit about me. Some people know me, many don't. My name is Davide Grandi, and I work as an inverter specialist for the technical support team of the geothermal and solar O&M unit for Enel Green Power. After I graduated from university, I spent basically the rest of my career in solar, working for about 7 or 8 years for an inverter manufacturer, and then moved to Enel Green Power, who's a owner and operator of renewable power plants. And about 2 years ago, I fell in love with the concept of reliability. That's why I pursued my maintenance and reliability professional certification, as well as trying to understand a lot of the predictive maintenance technology that are out there. Enel Green Power, for the people who don't know it, is an owner operator of renewable power plants. We are in about 30 countries worldwide for about 43 gigawatt of managed capacity. About 4 gigawatt are solar and 10 are wind. And in North America, we have about 5 gigawatt of managed capacity. That being said, let's quickly move to what are we doing today? What is the common maintenance strategy for inverters in a solar plant? What we do is, in all reality, most of the time is following the OEM manual, which usually is a list of activities to be performed on a schedule based. Every 6 months, go inside inverter and retorque the power connection bolts, and every 3 months go and clean the air filter. So all this, it's what is defined as preventative maintenance, which is literally, list of tasks that are based on a time schedule. So I was looking at this list and I said, okay, let's go and figure it out from, our reliability engineering material. What is the goal of preventative maintenance? And what I found from this great book that I suggest to anyone who hasn't read it yet is that the definition of preventative maintenance, or let's say the basis of preventative maintenance, is that equipment could be periodically restored to like new conditions several times before it is necessary to discard it. So what are we trying to do with preventative maintenance is actually trying to extend or push into the future aging effect. This is the pretty famous bathtub curve, which depicts the failure rate of an asset over time. Where we can see in the early life, we have a failure rate that is high and decreasing. That's what we also call infant mortality. We have a central part where the failure rate is constant and low, and that's the so-called useful life. And then as time goes by, we start having aging effects ramping up and increasing the failure rate. So again, with preventative maintenance, that is based on restoring the equipment to a like new condition, what we are trying to do is actually extend the aging effect into the future. Now, the question that we should ask ourselves, ask myself multiple times is it working? It's this strategy working fine? And here's the thing. Several reliability studies have been performed throughout a variety of industries, from airlines to renewable energies to fossil fuel energies. And they have identified that, first of all, there is not one single failure rate pattern, but there are about 6 and probably more that are still to be discovered. But what's more important is that only less than 20% of our assets show an aging effect of some sort, while the remaining 80% or more show a completely random distribution of failures. Specifically for electronics and power electronics, we are talking about 89% of failures are completely random. So the idea of pushing these aging effects into the future kind of becomes flawed at this time. The other thing to consider is that human intervention is clearly defined as the leading contributor to failures. And everyone has fun stories about the oil rag left inside a piece of equipment. Well, these are not just fun stories, but they happen for real. So every time that we as humans get inside the equipment, there's a chance that we might introduce a possibility of failure. So at the end of the day, we should ask ourselves, what is the value of preventative maintenance? We are trying to delay an age effect that rarely is there. At the same time, we introduce the possibility of additional failures just because we are inside the equipment. And so are we doing more harm than good? And what about warranties? Because that's an interesting topic. Most of the equipment manufacturers are going to say, well, I still need you to perform these activities to avoid, avoid the warranty get voided. So are we really doing preventative maintenance just for the warranty value? So how do we tie all this together? The reality is that we should start looking, actually we need to switch to a maintenance strategy that is based on the condition of equipment. So we don't perform an activity just based on the time schedule, but based on the health status of our asset. And how can we do it? Well, in all reality, some of it, we are already doing it. Because I think a lot of people that are listening today have seen pictures like this. This is an infrared thermography picture. In this case, it's clearly showing overheating of some power connections. Well, thermography is actually one of the most common condition-based maintenance technologies, where we can actually see the incoming of a failure before the failure gets catastrophic. Some may argue it's a late notice, because if something is hot, well, we are not that far away from the failure, but by all intents and purposes, it is a condition-based maintenance technology. In the last year, or in the last 2 years, the buzzword of predictive analytics or data analytics is getting a trend in the industry, and that's the same idea. We have data that normally we would have just dumped into a server, and now are getting used to see trends, see variation of these trends, and using them to predict whether a failure is occurring or not. So that's another way that we are already doing some sort of condition-based maintenance or predictive maintenance. However, there is so much that we can do more. Throughout my life, I've been lucky enough to be exposed to different kind of industries where the topic of predictive maintenance is, honestly speaking, much more advanced and much more common than what we are used in solar. So what are the technologies that we can grab from other industries? Well, for example, a very common technology in other industry is ultrasonic analysis. Using this tool, we can actually pick the ultrasonic emissions, so the sound waves that are outside the human hearing range, which are emitted by the equipment when arcing, tracking, and other kind of electrical events occur. This is quite common in other industries, especially also in the fossil fuel industry, especially for what concerns substation, transformers, power connection. So should we start looking at this technology as a way to identify failures in inverters, not just on inverters, even in other assets before they occur? Some technologies are using drive analysis to identify problems in a motor drive connection. Well, a VFD, a variable frequency drive used to control this motor, is basically identical to a solar inverter. So should we start looking into this technology to look at this kind of issues? And then we're talking about electric measurement. Is there any electrical quantity, any voltage or current or temperature that we should start measuring inside the inverter, on the IGBTs, on the capacitors, or in any other point for that matter, that can give us an early detection of a failure? These are the questions that as an industry we should ask ourselves and try to therefore combine all these technologies, starting with the one that we're already using, as said, infrared thermography and data analysis or machine learning, with technologies that we could actually grab from other industries: ultrasound, electrical measurement, and drive analyzers. Now, all this has also to be tied with warranty requirements, because then a big discussion needs to happen between our industry and the OEM, aimed towards the idea of figuring out what are the best practices. Why do we need to keep doing preventative if it has little value just to maintain the warranty live? So all these questions, it's they should be. We should ask ourselves, and we should figure out as an industry how to solve these topics. Now, is that enough? As far as a predictive or a condition-based maintenance, well, that's just a tool into the bigger topic of reliability-based maintenance. So how can we move towards reliability-based maintenance? Reliability-based maintenance, in all reality, is actually a much bigger cultural and process-based shift that starts from predictive maintenance technologies, but ties them into failure mode and effect analysis and asset criticality. So we can figure out for every failure mode of our asset, what is the best way to predict it or to prevent it. If we have a light bulb, we are not going to do any predictive on it. We're just going to run it to failure. On the other side, if we have a main power transformer, well, they might grant the idea of doing a lot of predictive analysis on that asset because it's a really important asset for our plant. The second wheel in this system is root cause analysis and precision work. where first of all, there is every failure needs to be analyzed in order to understand what is the root cause and fix the process or the system to make sure that that specific failure doesn't happen again. And what ties everything together is the planning and scheduling aspect, where all the work orders are planned in advance, and we are aiming towards reducing reactive work and try to enhance proactive and planned work, because that is an absolute indicator and that drives down O&M cost for our asset. So after that, I will just complete my my quick speech with a closing remark. Our assets are talking to us, and we are just not listening. Other industries have gone through the same issues, the same process, where they had to figure out ways to understand the health of their equipment, and now those technologies exist. The goal, I hope, that I conveyed with this presentation is actually to try to mobilize the industry in sharing information, sharing data, and sharing strategies, and talk with the other vendors, original equipment manufacturers, and others, in order to tie all this information together and understand how we can solve the reliability topic in our industry. With that being said, Diana, I give it back the control to you, and I thank you very much for your time.
Thank you very much, Davide. That was indeed very, very insightful. Really good presentation. And just to the audience, a quick note that I am getting your questions. They're here with me, and we will be discussing those in Q&A. Right now, I'm going to switch the screen to our second panelist, Andy Walker from NREL. He will be giving his side of the presentation, and then we will switch to Q&A. So keep sending them on, and keep in mind that we'll be covering them at the end. Thank you very much once again, Davide. And now, Andy, I will be sending you a notification. Beautiful.
Okay, do you see my first slide, inverter O&M strategies? Okay.
We do see it.
Okay, thanks, Diana, for creating this opportunity for us to get together, and thanks, Davide, for that great presentation. Some of the things that I say will follow right behind that. This is a word cloud that I got from Tushara Gunda at Sandia National Laboratory. I think she had one of her associates help her in developing this. It counts up the 350 most common words that show up in O&M work orders, and the more a word is in the center of this word cloud, the more it appears, and the bigger it is, the more it appears. So you can see inverter is front and center in here, and it's almost the only one that sticks out. Also from Sandia National Laboratory, this bar chart on the left-hand side shows of a count of inverter incidents, 1,227 of them associated with the inverter, and the other percentages, grid combiner, environmental AC disconnect, string module tracker, are all really small numbers of events compared to the number of events with regards to inverters. These statistics are just my judgment call that 60% of failures and 60% of downtime are associated with inverters. Discussing more data from Sandia, they collect for people that participate in their PV-ROM data collection program, where staff at Sandia National Laboratory collect fleet records of failure and repair data and try to fit them to, or just analyze that data using all kinds of data science, including machine learning, and that word cloud on the previous slide, but one of the outcomes that we use in our cost model is these failure distributions. So the data that Sandia sorts out would be the bar chart shown here. And then it shows how it fits with different kinds of distributions, Weibull distribution, gamma distribution, exponential, logarithmic. And we just use that red one, the Weibull distribution, in the cost model that I'll talk about shortly. But here's some of the data that was published by Sandia in a December 2018 report. And it shows what would happen inside of an inverter. First of all, for microinverters and string inverters, in our model, the inverter is just replaced. But for central inverters, it's broken down to components, data acquisition card, control card, IGBT driver, IGBT matrix, two other driver cards, and the other components like capacitors. So this kind of relates more to central inverters, where you would be working on these individual components: fan, IGBT, cooling, cycling, inverter AC, fuse, and ground and arc fault are the categories of inverter items that were reported in that December 2018 report. And you'll notice that all these beta factors are greater than 1. So that kind of follows up on what Davide was talking about. If the beta is greater than 1, then it's kind of an aging phenomenon, and the failure rate increases with time. So our failure rates are almost all of the type that Davide described as fatigue related, with failure rates that occur higher in the later years. But like I said, it depends on the type. So that discussion of replacing the components inside the inverter relates to a central inverter. String inverters, I'd have an inverter on each string of modules. That might enhance reliability, because when one of the two is down, the other one continues to operate, so I still get half of the production of the plant. And micro inverters put an inverter on each module, and those also enhance reliability for the same reason. It's unlikely that all of them will be down at the same time. And this is also a configuration which is pretty robust to different orientations and shading and other phenomenon that can reduce production. And then DC optimizer is kind of a hybrid of that, where I have a DC to DC circuit on each string, and then perhaps a central or more modular inverter plant elsewhere. So there's pros and cons with these. EPC contractors generally prefer central inverter because it's lowest initial cost. O&M contractors often prefer string inverters because they are, here's some several reasons. They're a modular plant which reduces lost production, provides rapid shutdown near the array. The string inverters and microinverters can provide detailed data through, some pretty sophisticated communications that they have available through those platforms. Most of the wiring downstream of where the inverters are located is conventional AC wiring. So from an O&M perspective, at least by one account here, basically 8 megawatts at one facility where they were paying their DC electricians $125 an hour to maintain the DC circuits upstream of the central inverter, whereas the more conventional AC electricians were costing them more like $80 an hour. So just having more conventional voltage AC wiring as the system enhances safety and O&M from a lot of people's perspective. As we said, if it's a micro and string inverter, a lot of times the inverter is replaced, which entails a cost, but and you would have to have a spare parts inventory to be able to replace them quickly. But it can be done with pretty much a low level of expertise compared to inverter tech that would have to diagnose and repair a central inverter. So for some of those reasons, microinverters and string inverters are taking over increasing parts of the market with those O&M implications. So the O part of O&M describes operations, and we expect operations to become much more interactive in the future. Like up to now, one might have thought that PV systems operate themselves and don't really need an active operator. But as PV becomes an increasing contribution to the electric grid, utilities are going to want to communicate with your inverter and involve some active controls. So some of the things might be to turn your inverter on and off, depending on the needs of the larger utility system, or to curtail the output, to reach out and change settings that would otherwise be autonomous, like it might not be in constant communication with the utility, but the utility might be able to reach out and control some settings. And examples of settings that it might want to reach out and control include low voltage ride through, low frequency ride through. It might call upon the inverter to source reactive power. And so the diagram on the right here shows the IEC approach of opening up the envelope between what the inverter can do, which is kind of in the orange there, what it must do, which is the blue there, and then this white area in between, which can be informed by interactive communications with the utility. So that's standard IEEE 1547, which is being referred to there. Cybersecurity is another hot topic. Basically, a lot of these platforms are predicated on the assumption that I'll just be able to take that blue Ethernet cable from my facility network and plug it into the inverter. That is proving to be generally not the case. And so some kind of separate data backhaul and communications might be required. We can't assume that we can use the site network even in a commercial or residential application. Some of these inverter issues are described in this best practices document. It's now in its third edition, available at this link. And that third chapter down, dependencies on PV system type, to kind of describe how the O&M requirements and plans change for microinverters versus string inverters versus central inverters. From 2016 to 2018, sponsored by DOE, we came up with this PV O&M cost model. And it also kind of allows us to consider costs associated with string inverters, central inverters, microinverters. It's available at this link in an online version at sunspec.org. And if you prefer an Excel spreadsheet version, send me an email at this email address. I understand Diana's going to make the slides available. And some of the written calculations behind it are also described in this link at the very bottom of this slide. So if you're interested in that cost model. But what we see is the cost is actually different every year, because it's based on those Weibull distributions for the Sandia measures, plus basically the working group's judgment on what they thought the failure distributions would look like for components that we didn't have any data for. And so you can see the cost is different every year, and it goes up over time as like I said, in our model, our betas are greater than 1, so we're looking at a fatigue-related kind of profile where the failure rates get higher as the equipment gets older, warranties expire, and on a per kilowatt-hour basis, the costs go up even more because we assume that the production of the plant is going to go down at about 1% per year. Within that cost model, the cost each year is developed by adding up 150 measures. So what I did is I took all the ones that related to inverter and put them on this one slide. So you can see on the left-hand side the activity description of everything that needs to be done. Just start and stop or reboot the inverter, replace inverter fan motor, manual reset arc fault trip, and all the measures listed down with their mean interval, which is like the Weibull beta factor, and their shape factor, which is like the Weibull alpha factor. So all of these are according to some distribution function of its failure rate or some prescribed interval at which a measure has to occur, like replacing an inverter fan or the PM type measures. So we add up labor and cost and come to a total cost of that measure. So trying to take into account this failure data in estimating costs. So in this example, which is a 10 megawatt ground mount system, the cost model's estimating that about 23% of the net present value of the lifetime O&M cost is associated with the I'm sorry, the first table there is the labor category, so it's inverter specialist compared to the other things like cleaner or inspector that you might have. And then the second table over is also showing that the inverter as a component is responsible for the largest share of the O&M cost in this model. So I can hand it back to Diana to start fielding some questions.
Absolutely. Thank you very much, Andy. That was really, really, really insightful. Thank you very much for sharing all this info with the public. I'm sure they'll think the same based on the questions that I'm receiving. Okay, so to kickstart Q&A, I think I would like to nominate each one of you to answer some questions. So I have one for Davide to start with. Davide, are you able to share any sort of real life examples, any case studies that reflect how a major failure has been predicted and then prevented using predictive technologies? Any info that you can give on that would be useful.
Yeah, sure. So let me start with the fact that, as I said, from what concern inverters today, from a predictive maintenance standpoint, they are still pretty much a black box, right? What we have done, well, I mean, of course, we are on one side trying to solve this topic. And gathering data on, in order to understand what the predictive maintenance technologies on inverter are. On the other side, we are starting using the predictive technologies that I shared with the audience before on solar plants, not just inverters, but everything: inverters, step-up transformers, medium voltage recloser, and so on. A great example that I can share is the use of ultrasonic technology on anything that is a power connection, whether it's a medium voltage recloser, a overhead pole, a step-up transformer sitting next to a central inverter. And one example has been in one of our sites. A site maintenance technician, while doing inspection with an ultrasonic sensor, he was able to pick a abnormal type of noise that would kind of be considered as something becoming loose, or something, mechanical looseness of some sort. Of course, since there is no silver bullet for what concerns these technologies, we start troubleshooting, we start using thermography and other technologies, and we were able to identify that one of the main connection inside a T-body in a medium voltage connection was getting loose. Just to give you an idea, the looseness was faint. I mean, there was very little thermal signature coming off the T-body. But if that connection would have failed, considering the lead time for that specific piece of equipment and the size of the plant, we probably would have taken about $500,000 in lost revenue only for a specific failure. That was identified prior to failure. At night, the same night, we went in, opened the T-body, cleaned the connection, retorqued it, everything was fine, and now the site is running fine since, ever since. So I think this is a great example that shows the capabilities of these technology and how quickly any cost associated to the implementation of it, whether it's tool, training, and everything, can quickly be recovered.
Wonderful. Yeah, that makes sense. Thank you very much for that detailed answer. I would like to ask you, Andy, a question now as well. So you mentioned different kind of inverters in your presentation. I was just wondering, we were wondering if it's actually recommended to replace central inverters with string inverters, or is that something that can only be done in initial design phase?
I think it's probably not cost effective to replace a central inverter with string inverters. So it is a decision best made in the early design phase. But that being said, I know that some projects are replacing central inverters with string inverters for safety and maintenance reasons. So one of them was that case where I mentioned where their DC electricians were very expensive compared to their AC electricians, and they also preferred the safety of the conventional AC wiring running around on the roof of their distributed generation applications. So for safety and maintenance cost reasons, people are doing it, even though it might not pencil out in terms of being cost effective or a cost savings measure, just because the string inverters and are an expense. And another thing I might want to caution about is if you just ask people to replace your central inverter with string inverters without redoing all the wiring and wiring management system, you won't yield the benefits. Like we have seen where people have replaced a central inverter with multiple string inverters that are located in the same location, the location where the central inverter used to be. So they still have all the DC wiring to maintain and not really getting the benefits. So reconductoring the plant or redoing the wiring and wire management system should be part of the thinking behind that change.
Sure. No, that makes a lot of sense. Thank you very much, Andy. It's definitely something to think about. And inverters in general, they are very sensitive, sort of delicate components. So one question that actually comes up quite a lot is around data loss and system reliability. So I would like to ask you both, and maybe you can take turns to respond to this. But what are your thoughts on the reliability and data transmission by these inverters? Can it be improved, and if so, how could it be improved? Maybe Davide, you would like to start.
Sure. So it can be improved. Definitely, yes. There are a few. There are some best practices that can be shared, which mostly are by design. We have, for example, seen a lot of benefit starting using all the whatever is the communication line, especially if it's copper, all the communication cable to put them farther away as possible, not just from AC conductors, but also from DC conductors, because in reality, the DC cable, they don't see a pure DC line, but there is always an AC superimposed on that. So this is from a pure physical standpoint that gives us better communication reliability. And on top of it, there are other strategies that can be implemented more on the SCADA point of view, whether it's data checking that the right data is coming in. Commissioning is a great moment to make sure that everything is running smoothly and the right tests are done to ensure good data reliability for the remaining life of the project.
Okay, that makes sense. Thank you, Davide. Do you have any thoughts on that, Andy?
It's not my area of expertise, so I can't offer any solutions, but I can share that the performance data that we look at is punctuated by really long periods when the communications are down. A lot of times the production meter keeps turning, so when the communications come back up, the production data is not lost, but it is an area which could use some improvement, but I'm not sure what the best strategies are for that.
Sure. No, that's still very useful, and I'm sure some people, if they have any specific questions, they can get in touch.
One tip that comes to mind is to isolate the communications from the inverter plant, or for and especially a battery plant. What I'm thinking is if there's a fire, like you want your communications to stay up and running. So I isolate them from components that might fail catastrophically, so that your communications can stay up and running.
Sure. No, that makes sense, and that's actually a really good tip. We're getting a lot of questions on the platform regarding the main KPIs that need to be monitored to ensure that the inverter is working properly. Is this a standard? Can you sort of expand on that a little bit?
Sure. So of course there are performance KPIs that can be monitored, and artificial intelligence, machine learning, they do a great job of it, trying to put everything together and see trends that we human cannot. All these and then I don't know, tying power data with irradiance and other data to understand where the inefficiencies are. This is all great. It's also really it's reactive in some sort of way, in the sense that does not really give an indication of, okay, these component inside the inverter is going to fail within the next 3 months or something like that. As I mentioned before, unfortunately the industry today, especially inverters, are sort of a black box for what concern predictive data. I think there are a lot of studies or pilots that can be done either in the using again machine learning, so tying together data that might not make sense in the first place, but there might be an underlying trend, as well as starting the discussion with the the IGBTs industry and the capacitor industry and the manufacturers of component. If I buy an IGBT, what are the electrical signal that I am going to look at to understand, okay, this IGBT is on the verge of failing? Right now, this conversation has not really happened yet, and but I've started seeing good, pretty good movement towards these discussions.
Sure. Yeah. And Andy, would you have anything to share on that question?
No, Diana, we can go to the next question.
Sure. We we noticed that problems can happen with the grid power, of course. But do you believe, and this one is specifically for you, Andy, do you believe that these problems with the grid power or the site load in general actually cause inverters to fail?
I think the answer is yes, and I could share a couple of anecdotes. One site in Florida we're looking at, there does seem to be a correlation between inverter failure rates and grid power coming on and off. They have kind of unreliable grid power on that particular circuit with lots of interruptions. And Another site in California I can think of, we're thinking that high inverter failure rates might have something to do with harmonic distortion that's caused by a UPS on the load side of the circuit. So it's based on just a couple of anecdotes, I think that things out on the utility circuit can exacerbate inverter problems. And Davide, do you have any info on that?
I would agree with you, Andy. I haven't seen any specific issues in the side that we manage, mostly because so far the grid has been relatively stable. But just for the physics of the how an inverter is working, I mean that doesn't surprise me at all, and it's good that you have data to kind of make this comparison. But in all reality, yes, I mean our inverters are equipment that they live inside a plant tied to the grid with other equipment. So anything that happens, whether in the grid or, potentially also on the DC side, can cause transient that are harmful to IGBTs and capacitors and filters. So I think that's a very good, it's a very good topic, a very good.
Wonderful. Thank you, both of you, for sharing those very insightful thoughts. Would you be able to give us a sort of very quick overview on, the most effective predictive maintenance tools to actually predict failure on inverters from your experience?
Yeah, I said right now, I can start. Right now, we the technology that we are using today is mostly for prediction, where it's mostly thermography, and there are some companies that started doing machine learning and data analytics. All other technologies are there. Most of them are already used by other industries, and it's just a matter to start using them and start understanding how they can fit to our equipment. I personally think it's going to be valuable also to start looking at drive analysis. There are some tools out there that are now used by manufacturing industry to look at the health of the variable frequency drives that are used in I don't know, any part of the process. And as said, from a technical standpoint, there are very few differences between a variable frequency drive and a solar inverter.
Wonderful. Yeah. Okay. Thank you very much. Yeah.
Yeah.
Andy,
I'd echo the temperature. Like I've seen dividends yielded by temperature, and not always thermography, but it might be a temperature sensor that's within the device and part of the reporting system. And I'm really excited about the other things that Davide talked about, ultrasonic and power analyzers and things like that. And I'm especially interested in things that can be done remotely without the addition of additional instrumentation. Maybe some signature that the inverter could produce itself.
Understood. Thank you, Andy and Davide. Actually, I'd like to ask one more question. We are quickly running out of time, but if you could briefly go through any specific, sort of challenge or major advantage of implementing a reliability-based maintenance process.
Yeah. So the advantages are huge. We're talking about pretty big cost saving. I think it's a common figure that reactive work is from 3 to 10 times more expensive than scheduled work. So doing reliability based helps scheduling the work before before the actually is needed. We're going to do our intervention when we want and not when the asset wants. There are huge safety consideration to take place. It's some studies that I was reading actually show that the instance where a safety incident is most likely to occur is a young technician with less than 3 years of experience doing reactive work. So there are also huge safety concerns on that point of view. The major challenge is that it's a process and a cultural based change, which means basically go back and take a very critical look of every single activity that we do in maintenance and understand if it provides value or not. And it's a major cultural shift. When we have done maintenance in that same way for, I don't know, 10, 15 years, it's difficult to look back and say, okay, you know what, maybe we did it wrong, but that's what it needs to happen.
Yeah, thank you very much. Andy, would you like to add anything to that?
I think safety is a good note to end on. That's a big driver among, something everybody can agree on: system owners, asset managers, O&M providers, and it's often the key motivator behind making some of these O&M decisions. Cost is important, performance important, but safety is more important. And there's a lot of it's kind of off the topic of inverters, but aerial thermography I think is a safer alternative to electrical testing. And analyzing the power signature coming back from an inverter or through a power analyzer seems like safer than doing electrical testing. So I think all these vectors are moving in the right direction in terms of improving cost, performance, and enhancing safety.
Yeah, that
thanks
makes
everybody.
A lot of sense. Yeah. Thank you. Thank you very much, Davide and Andy. And thank you to everybody involved. We are going to have to wrap up now as we are reaching the end time of our webinar. So yeah, once again, thank you, Enel and NREL, both of you, for making this webinar a huge success. We've had Davide Grandi from Enel Green Power and Andy Walker from NREL. They've both made this webinar a huge success, so thank you very much. We've actually had around 1,000 of you guys around the world joining us, so I hope you've gained even more than what you've expected from this great panelist lineup. So before you all ask, these recordings will be sent to you via email. It's really good that we know, a few things that we can do to perform inverter O&M a bit more efficiently, trying to predict failure, trying to, overall ensure a longer-term stability on PV assets. So we'll keep uncovering relevant stories at New Energy Update. You can subscribe to our newsletter on the website if you're interested. And we are always open for collaboration, future webinars and white papers and reports. So please contact me directly if you're interested to have a chat with us. And until then, thank you all for tuning in, and I hope you have a beautiful day. Thank you, everyone.